Very good morning, student. This is Rahul Garg, your maths teacher. Student, today we'll start a new chapter, that is chapter number 1, real numbers. If we talk about our final board exam, the weightage of this chapter is 6 marks. 6 marks question will be from this chapter, that is chapter number 1. And what will be the pattern? One question, 1 marks, and one question of 2 marks, and one question of 3 marks. Total 6 marks. And the chapter is very easy, and the question always repeat in every exam. So this is an important chapter because chapter is very small and the marks is very high, that is 6 marks, which will play an important role in our CBSE board exam. Now, without wasting our time, we start our chapter real numbers. Before move on, first discuss the numbers which we have already discussed in chapter 2, that is polynomial, and you learned this about the numbers in class 9. So our first number is natural number. Natural number denoted by capital N, and examples are 1, 2, 3 and so on. And second number is whole number and denoted by capital W. And when we include 0 in a natural number, then it becomes whole number. And the third number is integers. There are two types of integer, that is positive integer and negative integer. So all natural numbers and negative of natural number along with 0 are known as integers. These are the positive integer and these are negative integer. When we represent these integer on number line, that is 0, 1, 2, 3, -1, -2, -3, and the space available between 0 and 1 and 2, here we place the fraction number, that is 1/4, 1/2, -1/4, 3/4, 3/2, all are placed between these spaces, and these are known as rational numbers. These are known as rational numbers. And you know, the definition of rational number is the number which we can represent in the form P/Q, where Q is not equals 0, are known as rational number. Examples are 2/3, 1/4, 9/8, all are the rational numbers. And the last number is irrational number. Irrational number is the number which we cannot represent in P/Q form, are known as irrational number, and example are √2, √3, pi and so on. And all these numbers are known as real number. And besides real numbers, we have another type of number which we will discuss in class 11, that is complex number, which are not real numbers. Okay, this is not our topic. This will be discussed in class 11th maths. Now start our chapter, class 10 chapter real number. Our first topic is Euclid division lemma, that is theorem 1.1, Euclid's division lemma. So what is the meaning of Euclid division lemma? First, Euclid is name of mathematician, and division we will discuss now. Division is if we have two numbers, say 13 and 4. When we divide 13 with 4, we will get 1 as remainder and 3 as quotient. Then we write 13 as 4 into 3 plus 1. Means my left hand side 13 and right hand side will also be 13. 4 into 3 12 plus 1 13. So we can say that 13, which is known as dividend, equals divisor into quotient plus remainder. If I denote this with the symbol, that is dividend is denoted by A and divisor with B and quotient with Q, remainder with R, then A equals B into Q plus R. This is general form of division. This is general form of division. Now what is the meaning of lemma? Lemma means it is a proven statement which is already proved. It is a proven statement which is used to prove another statement. Means if this is our proven statement, then we will use this statement to prove another statement. This says that lemma. This is the meaning of lemma. Means जब हम किसी भी एक गिवन स्टेटमेंट को, प्रूवन स्टेटमेंट को यूज करके किसी अनदर स्टेटमेंट को प्रूव करते हैं तो उसको क्या बोलते हैं? लेमा. नाउ let's discuss Euclid division lemma. Euclid division lemma, the statement of Euclid division lemma is if A and B, if A and B are any two positive integers, then there exist two unique numbers that is Q and R such that A equals B into Q plus R. This is the statement of Euclid division lemma, which says that if A and B are any two positive integers, then there exist two unique number that is Q and R such that A equals B into Q plus R, where the condition for R is it should be less than B and greater than equals 0. So R should be greater than equals 0 but less than B, and A also greater than B. These two are the conditions for Euclid division lemma. Now, how we will use this statement to find out or and to solve any problem or to prove any statement which is stated by Euclid division algorithm. And next is Euclid's division algorithm. Now the meaning of algorithm is Euclid division is same. The difference is this lemma and the algorithm. The algorithm says that it is a series of steps used to solve a problem. Means where we use algorithm, then the statements mean is this: we will use this theorem to find out the solution of another problems. Now, how we will use this Euclid division algorithm to find HCF? You have already learned to find out the HCF by factorization method. But now we will discuss how to find the HCF using Euclid division algorithm. Finding HCF, and you know the full form of HCF is highest common factor. HCF using Euclid's division algorithm or Euclid division lemma. Because algorithm is a steps, we use Euclid's division lemma. Finding HCF using Euclid division lemma. Now in algorithm we write the steps. So our first step is, if we want to find out the HCF of A and B, where A is greater than B, then our first step will be apply Euclid's division lemma to A and B. Apply Euclid division lemma to A and B, where A is greater than B. Then it will be A equals B into Q1 plus R1, where Q1 and R1 is quotient and remainder respectively. Q1 is quotient and R1 is remainder. Now our second step is if R1 equals 0, अगर हमारा रिमाइंडर 0 आता है तो क्या होगा, HCF जो होगा, HCF of A and B will be B. If R1 is 0, then HCF is B. But if R1 is not equals 0, अगर R1 0 नहीं हुआ तो क्या करेंगे, then again apply Euclid division lemma. Then again apply Euclid division lemma on B and R1. This B and this R1. Now we know that this remainder is always less than this B. So now B is greater than R1, and while we are applying Euclid division lemma, this will become B equals R1 into quotient. Now quotient will be Q2 and remainder will be R2. Now step fourth will be if R2 is 0. If R2 is 0, then HCF will be this divisor. Here divisor is R1, so HCF will be R1. But if R2 is not equal 0, then again apply Euclid division lemma, and ये तब तक चलता रहेगा जब तक हमें क्या है, रिमाइंडर 0 नहीं मिलेगा. Then again apply Euclid division lemma till we doesn't get R equals 0. This will be better clear to you in next lecture when we will discuss question based on finding HCF using Euclid division lemma. Because in this lecture we have only discussed the theory, and the theory will be better clear to you when we apply this theory on our numericals. And in first we discuss the numbers, which we have already discussed in 2 times, that is in polynomial chapter and in class 9. And then we have discussed Euclid division lemma, in which Euclid is mathematician name, and division we know that dividend equals divisor into quotient plus remainder. And then in general form we can write A equals B into Q plus R. And lemma, the meaning of lemma is that it is a proven statement which we will use to prove another statement, or to solve numericals or problems we use this Euclid division lemma. And the statement of Euclid division lemma is, if A and B are any two positive integers, कि अगर A और B कोई भी दो पॉजिटिव इंटीजर्स हैं तो वहाँ पे Q और R दो यूनिक नंबर एग्जिस्ट करेंगे, जिसमें वो एक कंडीशन को फॉलो करेंगे कि A जो है वो B इंटू क्यू प्लस आर के इक्वल होगा, और जो R की कंडीशन होगी वो क्या होगी कि R शुड बी लेस देन B and greater than equals 0. For A and B, A must be greater than B. Now we will apply these steps, these Euclid division lemma, to find out the HCF, which will cover under Euclid division algorithm, because algorithms means is it is a series of steps, means it gives the steps used to solve a particular type of problem. Now, how we will find HCF using Euclid division lemma? Say if we have 2 points, two numbers A and B, where A is greater than B, then our first step will be apply Euclid division lemma on A and B. Then this will become A equals B into Q1 and R1 plus R1. Q1 is quotient and R1 is remainder. Now we will check the remainder. If remainder is 0, then HCF will be this divisor, that is B. Or if remainder is not equals 0, then we again apply Euclid division lemma to this divisor and remainder. Or the third step will be, and the next step will be, we will check again remainder. If remainder is 0, then our step will be stopped here, and HCF will be the divisor of the previous step. But if it is not equals 0, then we will apply the Euclid division lemma till we doesn't get the till we get remainder equals 0. Okay student, thank you student, and have a nice day.